Hey, good morning. Welcome to
KidMath number 63.
Good Math number 63. What do we got after this? Jemima problem?
Yeah, probably.
Yeah. Okay, so we moved on to the next section. We have been talking about parabolas, where our simplest example of a parabola was y equals x squared. Right?
Yep.
And we learned you can do lots of things to connect the geometry and algebra with parabolas. You can shift around. You can move up and down. You can even turn it completely sideways. How do you turn it completely sideways? What's the algebra trick you do?
X equals y squared.
You swap the x and y's. So x equals y squared turns this thing on its side. Okay. Now we're going to talk about circles. Okay. And our starting example for a circle. In fact, the most common circle I'll do centered at 0, 0 with a radius of 1. This circle has a special name. It's called the unit circle. This circle shows up in a lot of places.
Alright.
I saw it at the dry cleaners the other day. Okay, so unit circle centered at 0, 0 with a radius of 1. So all we're going to do today for this movie is find the equation of this circle. So this circle has a random point x, y on it, and we're going to find the equation for this circle. But before you jump into that, I'm going to erase and make it a little bit bigger so you can talk. Okay, so our simple example of a parabola, y equals x squared, everything comes from that, right? Either by shifting left, right, up, down, or shrinking, or expanding. You grab an eraser.
Alright.
Okay. With our circle, everything's going to come from this simple, basic example of a circle. Okay. So see if you can explain when you have our circle here. Well, close enough. This is a radius of 1, and this is a random point x, y. How do you find the equation of this circle?
Well, you can draw a triangle. So you get a right triangle. Well, maybe not a right triangle, but
Good question. Is this a right triangle or not?
well, you drop straight down.
You come straight down parallel to the y-axis,
Yes,
and you
so-
go straight across parallel to the x-axis.
So it is a right triangle.
It is a right triangle. Okay.
So this point is x, y. This point is 0, 0. Then this point here, you go over x, but you don't go up the y.
Okay.
This point is just x, 0.
All right.
So now, this is x, this is y.
What is x and what is y? What does that mean?
Well, this distance is
Ah,
x.
the distance is x. The distance is y there.
Well, the area doesn't seem to stay. It's not going to stay the same, because like when you have a triangle like that, the area is not going to be the same.
Okay, so the area of this triangle doesn't seem to come into play for now.
But the hypotenuse does stay the same.
The hypotenuse of this triangle, no matter how you draw this right triangle, the hypotenuse is always 1.
Because
Okay.
it's a right triangle.
All right.
So we could use that fact, and we know the Pythagorean Theorem is a squared plus b squared equals c squared
Okay, and that is true for what kind of triangle?
for a right triangle.
For a right triangle. So it was very important to determine if this was a right triangle or not, if we want to use the Pythagorean theorem.
So we can use this. So we have a radius of 1. So except the a and b are actually x squared plus y squared equals 1 squared, or 1.
Okay, so there you go. So now we have an equation. It says x squared plus y squared equals 1. Write the 1 squared, just so 1 squared, which happens to be 1. Now this is an equation that's different from stuff that you've seen before. Okay, usually we have y equals x squared plus blah blah blah, or sometimes we had x equals y squared plus blah blah blah. But here we have an equation, x squared plus y squared equals 1. Very interesting equation. And the graph of this equation is a circle. And all circles that we study are going to come from this, and that's what we're going to talk about over the next week.
Cool.
All right. Good job, sweet pie. Good job.